Awesome. Okay. Hello, everybody. My name is Holly Stotelmyer, and my presentation is using sklearn's Lasso algorithm, or learning about machine learning by analyzing a video game that I really like. So, real quick about me, my name is Holly. There's my Twitter, there's my GitHub. And as far as my knowledge before I went into the mentorship program, I knew that machine learning was a thing, and it involved a lot of jargony words like models and predictions and scorings and coefficients, but that was pretty much it. My project was mainly to kind of help me learn more about the practices and processes of how do you actually use machine learning to try and solve something for you. So with that, my problem. I really love Zelda Breath of the Wild, and one of the things I really love about this game is that you can build recipes throughout the game. The designers know whatever formulas go into like putting different ingredients together gives you like Z results, but gamers don't. And a lot of the fan wikis and chat sites is a lot of people kind of sharing anecdotes as far as like, oh, well, if you put these items together, then you get XYZ. But there were only a couple of fan sites that really had some tables of actual information of like how these ingredients, there can be 1 to 5, you put them together and you get different effects. You can have health or stamina, which is a set amount, or you can have a weather or a combat boost, which is a time duration amount. And they can be on different strengths. So since there was no guide on results, I thought this would be a good opportunity to see if I could use machine learning to try and solve some of these questions for me. So the process. As I mentioned, there's just nothing but rumors on the internet. So I tried to find any fan sites that actually tried to put their information in a table format so I could easily copy and paste that into a CSV and kind of work with it. So thank you, fandoms. Then I tried to figure out, what am I even going to try and solve for? Learning about machine learning, you have to have like something at the end that you're calculating for. So when I was looking at the different data, these recipes can sell for different amounts, so I thought I would try and calculate the sell price. Then I needed to format that data using a couple of different libraries, and then I needed to actually choose a machine learning algorithm out of a giant chart of all of these different algorithms, of all these different names and types, and then try and start actually testing and see if I can get the thing to work. So, prepping the data, this is just a quick screenshot of some of the work that I did. I primarily used some command line bash tools, CSV, and the pandas library. This little snippet was something that I had to create so that I could take a string that was just a list that somebody on the internet put on a table. So taking the string of a list of ingredients that were comma separated, kind of separate those out into different variables, clean them up, and then be able to use that so that I could use a term called one-hot encoding to then classify my data. Once I had my data in a decent format, I needed to actually figure out what model I was going to use. I used Lasso. Lasso stands for Least Absolute Shrinkage and Selection Operator, AKA, if you don't know data science jargon, this algorithm will do a lot of the dirty work for you in that if you have a lot of different features, so like I have all of these different factors into what like ingredients create a final recipe result, this algo will take all of these different features and kind of boil it down for me to figure out which features are the most important in calculating my sell price. And then it uses variable selection, finding my features, and regularization to do that. And then it'll give me a score at the end that'll kind of tell me how accurate I was. That score can be on a scale of 0 to 1. 0 is not good. 1 is also not good. It means that your algorithm is probably too rigid, and then when you actually test it in the wild, it's gonna miss. So that was something I learned. It's called overfitting. Libraries that I used, pandas, sklearn, and plotly. So here's a little bit of code. This was me kind of setting up Lasso with my training data set, and I have this lovely data frame. Each of those columns is an additional feature. For a small data set, I had 359 different features. So it was interesting to see how quickly it grew. And then once I used that, I wanted to try and score my model to see how accurate it was, and I got a score of 93. That's amazing. It's not too bad. I could still try and look at my data and try and root out some bias and variance and get that score a little bit better. But again, I don't want that score to be 100. And then I wanted to make some fancy graphics. I'm running out of time, sorry. So real quickly, just so I can show you a chart, I used principal component analysis and Plotly to try and put together some visualizations. And this is actually where I kind of ran out of time on the mentorship. So things that I want to work on, small data sets. Formatting CSVs, I didn't use pandas as much as I wanted to. I kind of leaned on my existing Python knowledge, so I would love to build that out a little bit more. And then visualization, more than just a regression line. I want to, make it fancy. And that's it. So thank you, Kevin, my mentor, and thank you, ChiPy.